Hi everyone, I'd like to welcome you to HNL, short for the Human Neuromechanics Lab. Here we focus on the neural control and biomechanics of human locomotion. We use a range of techniques in biomechanics, neuroscience, and biomedical engineering to study how humans walk and run. Under Dr. Daniel Ferris, our goals are to develop new technology for assisting with human locomotion, merging human and machine with mechatronic brain-computer interfaces. You can learn more about him and the lab through our website, but enough about that, you're watching to see more about the lab space itself. In HNL, we have a computer lab in the new engineering building, where most lab members do the majority of their data analysis and research prep, each with their own dedicated computer and workspace. We also have a couple of 3D printers that are housed in this back room. However, our main space is in the Particle Science and Technology building, where we have a fully equipped lab built and maintained to fit our specific needs. We have a variety of instruments, tools, and devices at our disposal to aid our students in their testing endeavors. I'll show you around a couple of them. We use a variety of systems to see what your body is doing during specific tasks. From EEG recording brain activity,
you blink for me 3 times real fast, blink, blink,
to EMGs recording muscle activity, and IMUs recording movement, to insoles recording ground reaction forces.
Shift your weight to the right.
This only scratches the surface of all the amazing tech our lab has at its disposal. One of the first things you notice when coming into the lab is this bad boy, the hexapod. It was specifically made for our lab and it's capable of moving in any direction in 3D space. We use it for a lot of phantom head testing. Phantom heads are ballistic gel heads made to mimic the conductivity of a human head, which we then send known electrical signals through. While it's moving, we use EEG to measure these signals. We can compare the known and measured signals to see how much noise the motion introduces to the system, allowing us to develop new and better data cleaning methods. One of those methods is something that our lab has pioneered in the EEG field, the dual layer EEG system. Essentially, we take 2 EEG electrodes and glue them together, one facing the subject's scalp and the other facing outwards. The one facing the subject is recording the brain activity and the noise, while the one facing out is only recording the noise. We can essentially subtract the two, allowing us to cancel out the noise and return clean data. While it's not as simple as I make it sound, our lab has developed many methods to work with this data, allowing us to see brain activity in ways and situations that people haven't previously been able to do, from playing tennis, or playing ping pong, or adapting to odd walking strides. That brings us over to the Burtech, a force-instrumented split-belt treadmill. Force plates in the treadmill allow us to measure ground reaction forces while a person is walking, which we can then use to do inverse kinetics and determine joint torques and other metrics. This treadmill uses 2 belts that are able to be controlled to move at 2 different speeds simultaneously. The treadmill itself can also be inclined up to 15 degrees. The lab also has another set of force plates, the AMTIs. These are 3 in-ground force plates used for overground walking, such as this situation, with an in-lab made body weight support system. The lab also has a motion capture system comprised of 20 cameras all positioned around the room. Similar to the systems used in the movie industry for your favorite films like The Avengers, this system allows us to capture a body's movement in space in order to get important biomechanical data. It's also just fun to watch. The HNL lab always has a variety of projects going on, as you've already seen. We've worked with multiple exoskeletons, such as Lockheed Martin's Onyx knee exoskeleton, and passive knee exoskeletons designed and developed in lab. 2 different projects, one using DeFi's ankle exoskeleton and the other using robotic prostheses, are working to integrate EMG muscular control into their respective systems. We also have projects dealing with the behavioral and physiological changes players experience when playing ping pong or computer pong. We are also involved with the multi-lab mind and motion study, which uses uneven terrain treadmills to understand and predict how older individuals wind up with gait impairments and instability. Other projects focus on balance training with visual impairments. All in all, the Human Neuromechanics Lab has a wide variety of projects, all of which tie back to our main goal of understanding human locomotion and making strides towards improving it. If that sounds like something that interests you, then please consider becoming a part of the team. We'd be happy to have you.